Hi guys. So I'm going to go over the homework answers right now. This is my little Italian guy with no foot, 1 foot. So I'm going to go over the answers and then you let me know if you have any questions, all right? So I will not take any more submissions of the homework after this video because obviously I'm giving you the answers. Okay, so let's start. So we are finding what are the domain of these functions, right? And as I discussed yesterday, the two things you have to look for are
they were in the
radicals.
car going to Houston, but then Cleo threw up.
Sorry, my daughter's talking to her teacher. So it's the set of all real numbers, right?
Because of her.
Not anything imaginary.
Superdome was filled.
Sorry. Okay, so we're checking for radicals, right? Any radicals with like square roots or fourth roots of even degree, right? But we're only doing square roots. So whatever's under the radical sign, right? Your radicands cannot be negative, right? We know that. So that means it has to be greater or equal to 0. And then the second thing we're going to look for is your denominators. Your denominators cannot be 0, right? We know that rule. That's undefined. So those are the two things we're looking for. So the first one, you really had no work to do. There's no radicals and there's no denominators. So that means the domain is all real numbers, okay? All real numbers. There's no restrictions. So I know we didn't really discuss this way of writing, but you can write x. This is x such that x belongs to the set of all real numbers, okay? If you didn't know how to write that, you could just write x such that x is all real numbers, right? And then interval notation is just, it goes all the way from negative infinity to positive infinity. So on the number line, it's the entire line. You would just shade the whole thing from negative to positive. No restrictions, all real numbers. This is just a parabola, right? And as, if you remember, parabola, the domain is all real numbers, okay? Next, we have B, okay? So here, I don't have any radicals, so I don't have to worry about that, but I do have to check this denominator, okay? This cannot be 0. So x squared minus 4 cannot be 0. So that means whatever would make it 0, that's what you can't have. So set it equal to 0 and solve for x, right? And that's what you can't have. So if I solve for x, I would add the 4 over here, right? So I get x squared equals 4, right? Then I square root both sides, so I have x equals positive or negative 2. So that's what we can't have, right? We can't have this because that would make the denominator 0. So set it equal to 0, solve for x, and that's what you can't have because that would make the denominator 0. Okay, so anything works. So if I were to graph it, I have everything on my number line is red here, except for there's a hole at negative 2 and positive 2. All right, so in set builder, I would write x such that x cannot be negative 2 or positive 2. Okay? Now with interval notation, you got to do each piece here. Okay? So this piece is here, negative infinity to negative 2, right? Not including. Union, this piece is negative 2 to positive 2 with parentheses, not including them, right? And then this piece is from positive 2 to infinity, not including the 2. All right, so that would be the interval notation for that. I didn't specify which way you needed to write it this time, so I would accept whichever you put. Okay? And then this, C, is no denominator, but we have a radical. So I know that this radicand, right, has to be greater or equal to 0. It can't be negative. So then I'm just going to solve my inequality, right? I decided to move this over here, so I made it positive, right? I'm a little bit blurry right now. There we go. Okay, and then I divide by 3, so I have 4/3, right? T is less than or equal to 4/3. I just rewrote it this way because I know you guys, we see it with the variable on the left side. So it's as long as it's pointing the right direction, right? Pointing this way, eating this. So T is less than or equal to 4/3. Okay, so that means I'm here, including the 4/3, all the way down, less than. This would be my set builder notation, right? T such that T is less than or equal to 4/3. And then my interval notation, right, from negative infinity all the way up to 4/3 with the bracket including 4/3. All right, and then the last one, guys, you know that I did this already once before and I realized that I wasn't recording. I wanted to die. But anyway, all right, so this one has both, right? So 1, we're going to do the check our radicals. 2, we're going to check our denominator. So first, this, right, 3x plus 12 has to be greater or equal to 0, right? You cannot have the negative under the radical there. So again, I'm going to solve my inequality here. Subtract the 12, divide by 3, right? So I get x is greater or equal to 4, okay? And then my denominator, x minus 5, cannot equal 0. So that means, right, you would solve x cannot be 5 because the 5 would make this denominator 0. So my domain is x such that x must be greater or equal to negative 4 and x cannot be 5. So for my graph here, there's a big hole where x is 5, right? And then it's everything greater or equal to negative 4, except it just not at 5. Okay, so with my interval notation, there's 2 pieces. This piece, right, from negative 4, including, up into 5, not including, union, and then this piece is 5, not including the 5, up to positive infinity. All right, so I hope that cleared up any questions you had. Let me know. Today we'll discuss, and we can review more Monday. Okay, have a good weekend.